Thank you. Can you hear me okay?
You sound great, and we can see your presentation. So whenever you're ready, you can begin.
All righty. Good afternoon, and thank you for joining me for my capstone presentation. My name is Mary Lewis, and I work for Blue Water Baltimore. My project is improving volunteer turnout with location-based data for Blue Water Baltimore. A little bit about me. I work for Blue Water Baltimore as the manager at their native plant nursery program, Herring Run Nursery. I do not currently work in the GIS field. This master's program is my first step in changing career paths. Prior to this program, I had no experience with GIS, so I've been completely blown away by my classmates' presentations, Matt's earlier today and everyone's yesterday evening. On a more personal side, I'm an avid hiker and I love to travel with my daughter. And this is a picture of us from spring break at the Desert Botanical Garden in Phoenix, Arizona. Today, I will do a brief overview of our organization, Blue Water Baltimore, the problem that this project aims to solve, the supporting research, the solution I came up with, the data I used in the solution, and we'll have a little preview of the application and end the presentation with a few takeaways. Blue Water Baltimore is an environmental nonprofit organization working in Baltimore City and Baltimore County, Maryland. The mission of the organization is to restore the rivers, streams, and harbor, to foster a healthy environment, a strong economy, and thriving communities. We'll be focusing heavily on the strong communities work today. This mission is supported by about 20 staff and thousands of volunteers that work in 5 key programs. First and foremost, we have the Baltimore Harbor Waterkeeper, which is the heartbeat of our organization. This team is responsible for monitoring water quality at 51 stations in the streams, river, and harbor. The Waterkeeper team is also responsible for responding to pollution reports that are submitted online and by phone. And additionally, the data collected by this team and the support of our membership allows us to hold polluters accountable by taking them to court. And we've had several victories in this department over the past few years. Next, the advocacy team works closely with the Waterkeeper to advocate for legislation that supports clean water and strong communities on a local, state, and federal level. This team has organized rallies, provides testimony for legislation, and partners with local politicians. The eco-literacy team is responsible for bringing environmental literacy to people of all ages in Baltimore. The educational programs range from fog monster workshops pictured here, fog standing for fats, oils, and greases, the things you should keep out of your sink drain, to the urban water cycle, the current health of our waterways, and conservation landscaping practices. Blue Water Baltimore's restoration team will be the main focus of this project. This team is responsible for tree plantings, tree maintenance, tree giveaways, and working with engineers to install green stormwater infrastructure in and around Baltimore. Lastly, where I work, the nursery program is unique in that it is a standalone retail operation, selling plants native to the Chesapeake Bay watershed. Staff and volunteers assist customers with choosing plants that are most suitable for their yard in order to improve stormwater management and increase conservation practices in the community. All the money raised by plant sales at the nursery result in unrestricted funding for the organization. Okay, so one big problem we have at Blue Water Baltimore is recruiting volunteers. The restoration team has the most volunteer opportunities available, and the problem is we need to get these trees into spaces like this with the help of our wonderful community members like these folks. Data provided by Blue Water Baltimore shows that for all of the year 2023, there were 3,131 individual volunteer opportunities to be filled, and just under half of those positions were filled, 1,450. For the spring of this year, 2024, 1,059 opportunities during 30 different events have been posted to the website and linked in the newsletter, and of these, only about a quarter have been filled, 382. Many hands make light work, and we can use location-based data that Blue Water already has to improve our turnout. Some research done for this project, it was firstly on volunteer recruitment. Research has shown that the problem of recruiting volunteers is very common in the nonprofit sector and not something that just us at Blue Water Baltimore have to manage. There's several reasons for why this is so difficult, from organizational management to individual motivations. And the less diversity of volunteer jobs, the more of a struggle it is to recruit. With most of these volunteer opportunities being with the restoration team doing tree plantings and pruning, it's a very homogeneous opportunity. The best way to improve volunteer turnout and experiences is to build on the sense of community, which also supports the mission of Blue Water Baltimore. Folks are more likely to return as a volunteer if they have a positive experience and they feel that they're making an improvement in their community, and if they're having fun doing it, like these guys. This project seeks to identify volunteers who have worked with us in the past within close proximity to a future event in need of support. This way, we can send a direct invitation to encourage repeat volunteers while building a sense of community. Additionally, many volunteers like to feel like they are making a positive impact. At Blue Water Baltimore, we feel that planting trees is a great way to do this. Additional research was done on usability. A lot of it seemed pretty intuitive, but it was great to find research supporting those intuitions. When building any web mapping application, it's important to consider the usability through all stages of the project development. Research has shown that it's important to keep distractions at a minimum, include only what is necessary for the map to work as designed, and additionally, mimic popular platforms like Google Maps whenever possible. So the solution to this problem of volunteer recruitment is to create an interactive map application that allows Blue Water Baltimore staff to identify these volunteers that have worked with us in the past and send direct invitations. Blue Water Baltimore has collected data over the last 15 years, and we have within Baltimore City and Baltimore County 3,863 folks who have helped us at least once. This tool also in the future can be used to build trust within the community, and we'll talk about that more at the end of the presentation. So there were a few key layers that were needed to make this idea come to fruition. First was the volunteers, as I mentioned, 3,863. These addresses were exported in a spreadsheet from Blue Water Baltimore Salesforce database. They were then filtered within the spreadsheet to remove anybody that lived outside of Baltimore City or Baltimore County. The reason for doing this filtering before uploading the spreadsheet to ArcGIS Pro was so that when it came time to geolocate the addresses, it would hopefully use less credits. So the spreadsheet was then added to ArcGIS Pro and the addresses were geolocated. Another layer that is important to include on any map created for Blue Water Baltimore is our water quality monitoring stations. This data was sourced from our Waterkeeper website, which is howsthewaterhun.org or baltimorewaterwatch.org. The data is free to export in an Excel spreadsheet, and all of the latitude and longitude are provided for each monitoring site. So I used XY table to point in ArcGIS Pro to create the symbology for these. Next, we have trees planted. This layer was created by Blue Water Baltimore staff prior to the start of this project. It includes all 12,802 trees planted by or in partnership with Blue Water Baltimore from 2008 through 2023. This layer was included to add data for communications. When we email folks looking for assistance, we can say things like, we've already planted X amount of trees in your neighborhood, and thanks to support from people like you, and we could really use your help with this next one. This layer was also included for the long-term goal of how this project could be expanded over time, where decision makers at Blue Water will be able to quickly see where tree plantings have historically been focused and where they might want to look for future sites. And lastly, Baltimore's neighborhoods were included in order to drive home the sense of community. Baltimoreans, like many other urban residents, take pride in their neighborhood, and it becomes a part of people's identity. We can incorporate neighborhood names in the invitations to specific events as a way to drive home the mission of building our strong communities. Once all of the layers were formatted and symbolized in ArcGIS Pro, it was then converted to a web map in ArcGIS Online to be used in Esri's Experience Builder. So I have a video demonstration of how the tool works. I'm just going to talk through it. I took a video in case there were any lags with the internet. So let's see how it goes. So in the upper right-hand corner is the search widget, very similar to Google Maps. Here I'm typing in the address for an upcoming planting that needs more help. You can select it. The map will highlight the area and zoom to it. And then on the right here, you can select by rectangle or select by circle, and this is going to select records within that area. So here I'm going to select by circle, turn on the tool, click and drag, and then we can see that in this small radius around this upcoming tree planting, we have 119 existing volunteers, and we've planted over 3,000 trees. That's really great, but we want to reach out to those people directly. So we can open the table and we can export the table to a CSV file. And then when staff open the spreadsheet, they can find all sorts of information, but most importantly, first name, last name, email, and the number of hours they've volunteered with us in the past. Oops. Sorry. So some key takeaways and future work for this project. A main takeaway I had throughout the capstone process was to hone in on a project that can solve a direct problem. Originally, this was a much larger scale project and it didn't solve any problems. So it was nice to bring the focus down. And as far as data collection, there were other layers I had hoped to include in this map, and due to it being the busy season and limited staff at an environmental nonprofit, some of those layers could not be sourced in time. I really enjoyed working with Experience Builder. I found a lot of the default settings to really jive with a lot of the usability research that I had done. One thing that I did have to change was for the search widget. When it zooms to the map, it zoomed in very close to the point and you couldn't get a feel for the general area. So I changed that setting. And long-term maintenance of this project, will be adding future data to the map. The spreadsheets and attribute tables, I did not delete any columns from because they are exported from existing data sources and imported right to the map so that there's no pre-processing necessary. It's all just stayed the same. And we have one restoration staff person in charge of uploading trees to the existing layer and one IT person responsible for adding new volunteers to the volunteer layer. And both of those staff people have experience with Esri products. And throughout the project, I learned how to solve a real life problem with GIS, and that was really exciting to me. That is all I have today.
All right, that was a great presentation. I loved your images and your pictures, especially the fall kids. They looked like they were having a great time. So,
Thank you.
You have a question already in the chat window.
Okay. Beth mentioned, have I talked to Esri about the credits you have to use for geolocations? It seems like they may give you credits to nonprofit groups like yours. I have not, but I know that Esri has definitely worked with us in the past. So that's definitely something to consider. When I was building this, I was using my Penn State account and just wanted to see how I can make it work. Another question was about asking about ongoing maintenance and updates to the data, which I mentioned. And Blue Water Baltimore's response to the work has been positive. They are very excited about this tool. There are some limitations to it and things to be addressed in the future. For example, if we export a list of volunteers and half of those people have already signed up for the event, and we're again asking them to sign up again for the same event. So things like that can definitely be addressed in Excel. But incorporating that data for a future version would be wise. Another question is, did I need to worry about making your app mobile friendly, or will staff always be using it on bigger screens? This will always be used from a computer. We do all of our event planning from the office and never from the field. Originally, this project was gonna also incorporate a way for the restoration team to keep track of maintenance from the field, and that part of the project was eliminated over time. But room to grow in the future.
Yeah, kind of a follow-up question that I had. Obviously, volunteers are the backbone of your organization. Uh, have you thought of any ways that you could leverage what you've created to help either recruit new volunteers or identify locations, neighborhoods where there aren't volunteers at present, but you could target recruitment in those areas?
Yeah, I think that is a really great idea. We attend a lot of community meetings and events in Baltimore neighborhoods. So being able to look at the map ahead of events like that and see, wow, we have a lot of volunteers in this area. Let's be sure to shout them out at this event, or we're really lacking in this neighborhood. And having volunteers with us to sort of promote their job with us at events like that would be a benefit. So I could see how that could grow our team in the future.
Popped up for you in the chat
Oh,
window.
another question.
Yeah.
I noticed you could export an item below file types like Excel, JSON, Geo, JSON, etc. What was item for? Matt, that's a very good question. I think that would be if you wanted to export and create a new layer, I'm assuming is what that it would be just a different type of export, but I have not messed around with that, so I will explore. And Professor D said that he encourages me to consider making a public-facing app showing our past work too, and that would be the dream. That will be the next step, I believe.
Yeah, I also work for a nonprofit, and we have an app that we use to show congressional members of all the work that we do. And we update every year. It's pretty cool.
Right?
Does your company have do you have an Esri with your company?
We do. Yep, I don't have an account on it. I think we have 2 logins for our account. So I think that's also something that I could reach out to, as Beth pointed out, as a nonprofit, that maybe we could get some extra seats for free.
It's $100 for a pro license and a creator. It's like the new GIS professional advanced, and it's $100 for a nonprofit to get that a year. It's pretty good pricing.
Thank you. I just wrote that down.
All right. Thanks again, Mary, for a great presentation. If you could put your contact info in the chat in case someone wants to follow up, that'd be great.
Thanks.
And Laura, if you want to go ahead and start sharing your screen, I'm going to get your presentation rolling here. there. Maybe she stepped away for a minute.
Whoops, sorry, I was double muted. It's my
Oh.
bad. I have a headset that mutes, so I always forget to unmute it. Okay, so my name is Laura Hurst. I'm presenting my capstone for using normalized difference vegetation index to determine
And
vegetation. Can you hear me?
we need you
Sorry.
to share your screen.
Oh, you're not.
No, we don't
Sorry.
see your presentation yet.
Oh, sorry. Wow, all my technical difficulties today. Here we go. There we go. Can you see my screen? You can hear me?
Yes.
Okay. All right. So my presentation is for using normalized difference vegetation index to determine vegetation health after the East Palestine train derailment. So about me, I'm from Cleveland, Ohio, about 80 miles west of the train derailment. I originally got my job where I currently work at Report All USA in 2020 after I got the GIS certificate from Penn State. And I started as an intern, quickly became part of the data team, and then I was just recently I was promoted to the lead GIS data engineer. My job is acquiring and normalizing large data sets. I load the data to the servers and QA that data. I also I'm a technical lead, so I create data initiatives and provide scripts and tools for our team to keep us on target with data freshness. Last year I got to go see, I go to the Esri UC conference where I met Jack Dangermond, who's featured in the picture. It was very exciting. All this to say, I don't work in remote sensing currently. I'd like to try and move into a field like that. I'm getting my certificate in remote sensing and Earth observation with my MGIS, but the study is relevant to me as a Ohio native. So the goals of my presentation are to present the background of the East Palestine derailment, demonstrate or show the effects of vinyl chloride, and demonstrate the value of using remote sensing methods to evaluate vegetation health, and then outline my project methodology and data used, discuss the results and conclusion, and then review the lessons learned and suggestions for future studies. So I'm sure most people here are familiar with the East Palestine train derailment, but as more background, in February 2023, last year, a Norfolk Southern train was derailed near East Palestine, Ohio, and was carrying chemicals, including 450 tons of vinyl chloride, also butyl acrylate, isobutylene, and ethylene glycol and ethyl hexyl acrylate. But for this research, I'm going to focus on vinyl chloride. The incident prompted evacuations and then a controlled burn to prevent potential explosions from the gases near burning train cars. It raised a lot of concerns about short and long-term impacts on the economy, environment, and people's health. The Environmental Protection Agency, or the EPA, was monitoring water and air quality, and shortly after the derailment said it was safe enough to return, but advised private well owners to conduct water tests and conducted sampling for months after the derailment. And Norfolk Southern actually took extensive measures and removed 167,000 tons of contaminated soil and water, and committed to ongoing monitoring until this month, actually, this year, and probably might have continued since then. After the derailment, there was a lot of distrust in the government because this scenario was compared to Flint, Michigan, in a lot of news resources. And nobody trusted Norfolk Southern and the EPA. If you dropped a stone in a still river, like in figure 2, it would kick up all these chemicals and look like gasoline when you see it in puddles outside of a gas station. And that was on news sources, and you could see it on Instagram from locals in the area. There's also thousands of fish dead that were reported, and it's, I think, 43,000. Yeah, 43,000. That's shown in figure 3. I have a family, I have friends of my family that live in the area, and they have animals. And one of their concerns was if they have horses drinking the water and eating the grass in the spring that had been grown exposed to the air, water, and soil, if they could have been affected by the chemicals in the derailment, and if so, would they get sick and die like fish? I thought this question could partially be approached by examining at least vegetation health using vegetation indices calculated from remote sensed imagery. So there's a little research on using remote sensing to evaluate vegetation health after a chemical spill. So my goals for this project are to determine if remotely sensed imagery and NDVI can be used to monitor vegetation health after chemical spills, and to see if there was any noticeable change after the chemical spill in East Palestine related to the train derailment. So over the next few slides, I'll discuss my reasoning for applying remote sensing for this topic. So it's important to see what we know about vinyl chloride and why we should worry about plants and human health. It's a lot of research was done on vinyl chloride because it was less regulated back in the 1970s and had bad effects on people in industrialized areas. It's used to make PVC or polyvinyl chloride, which is in plastic or PVC pipes. Humans can be exposed to this by inhaling polluted air near contaminated sites, drinking contaminated water, ingesting foods with vinyl chloride. And East Palestine residents were experiencing these side effects of vinyl chloride, like headaches, respiratory difficulties, skin, eye irritations. It's also a carcinogen. Keelhorn et al., which I got a lot of vinyl chloride research from, they discussed a train derailment in Germany in 1996 that had 250 tons of vinyl chloride that was burned. And as a result of this exposure, 29 people had increased chromosomal aberrations. It's also important to note that it's unlikely to ever break down in the environment, which makes it concerning for the area of East Palestine. The environmental research done by Singh et al. Showed that emerging contaminants like pharmaceuticals, surfactants, pesticides, and others like that can leach into soil and be absorbed by crops. And the plants absorb both beneficial and minerals and contaminants equally. But these chemicals use water as a medium and can persist through the hydrological cycle. Sieb et al. Conducted water and air quality samples independently from the EPA and by collecting rainwater samples, and they tested the acidity levels and the vinyl chloride content. And they saw a vinyl chloride content that was above what was permissible and more than what the EPA reported, and more acidic rain closer to the derailment site, with levels returning to normal over time, which does make it seem like the water could impact crops if its vinyl chloride levels are detected in rain and other vegetation. Similarly to vinyl chloride, pesticides also don't break down and accumulate within human bodies in fatty tissue, breast milk, and blood. So what's achievable using remote sensing? I'm sure most of us are aware that remote sensing is a very effective way to monitor vegetation health due to the spectral characteristics of plants. Research done by Rivard et al. Demonstrated that plants exhibited the first signs of stress in lab plants visible by spectral signatures with between 48 hours to 1 week after the stressor is introduced. Different materials have different spectral characteristics due to how they absorb and reflect energy. Like in figure 4, this is a spectral reflectance curve for vegetation. You can see that they reflect near infrared highly, as well as green and like different reflectance in the shortwave infrared spectrum as well. Spectral indices are combinations of the pixel values from 2 or more spectral bands in a multispectral image. NDVI measures the greenness and aids in monitoring stress in vegetation, which is helpful for this research. I wanted to use additional vegetation indices like GNR and GSWIR, which was used by some research I'm about to discuss on the next slide, but there was not enough literature to be able to interpret the values effectively. So because there is a current gap in research for remote sensing using remote sensing to evaluate chemical spills regarding plant health, this could be because chemicals are difficult to attach to any outcomes on plants without extensive lab work. However, oil spill research using remote sensing with vegetation indices is well documented and could work for chemical spills using spectral data. Oil spills have noticeable effects on vegetation, and Adamu et al. In 2016, and also they did further research in 2018. They utilized Landsat 8 imagery and NDVI on pre-spill and post-spill imagery, and notice on average the longer period between the oil spill and image acquisition, the more the NDVI values improved, and that oil spill sites had a lower NDVI than non-oil spill sites. The length of time it took for NDVI to improve was related to distance, toxicity, and the volume of the oil spill. Figure 5 is the area of the Nigerian delta that they were reviewing. And it had experienced regular oil spills over, I think, a decade. And the green spots are where all of the oil spills were. So they had a lot of data to go over. To do research like this, it requires a higher frequency of satellite returns to be able to capture the event properly, or a higher temporal resolution. So Sentinel-2 imagery at 10-meter resolution seems like it would be better for my research compared to what they use Landsat 8 at 30-meter resolution. Which brings me to my data and the research I'm doing. So I acquired the USDA National Agricultural Statistics Service crop cover data layer from 2022. It's a 30-meter resolution geotiff. I also I use this to extract vegetation classes to help get an idea of the crops in the local area. You can see the geotiff in figure 6, and the crops that are predominant in the area are definitely corn and soybeans, which is not surprising for Ohio. This gave me a good idea of when I should acquire imagery based on crop growth. So I wanted to make sure that the fields weren't barren, which would pull down some of the results. So I got Sentinel-2 level 2A imagery from May 1st and July 5th in 2021 to use as a control to compare my 2023 imagery from May 21st and July 5th. Those were chosen based on cloud cover, trying to avoid dates that had too much of it in it. The time of year that the derailment was in did impact when I could get my imagery to monitor vegetation. I needed it to reflect more spectrally, and there's less greenness to observe in February, so I had to pick dates that were later in the year. A point layer was created I also created a point layer to store the NDVI values and within the testing locations within each class for each image and index. I had to isolate the 3 variables to try and interpret NDVI values in relation to the train derailment. I used the image acquisition dates to assess NDVI values over time, which was May and July of 2021 and 2023. And distance to interpret any change in NDVI in comparison to the derailment location. And vegetation cover like crops, forests, and grass and pasture, because NDVI values could vary within each class. So I wanted to account for that. Figure 7 is the study area of what I used, and I also separated my points by buffering to help me compare better. All my image processing was done in ArcGIS Pro. I had to create composite images first and then NDVI outputs for each image. And then I used the USDA NASS crop cover data layer to classify crops, forests, and pasture. This is 30 meters, so mixed pixels are expected. I wanted to classify the imagery myself in eCognition, but I needed LiDAR data to create an NDSM to classify vegetation better and differentiate between forest and grass pasture and all that, but it just wasn't available for the whole study area. I then generated points within each class and buffer. These were systematically done about 40 meters apart, and the NDVI values were extracted to the testing points to store pixel values at each index. And then I removed all the NDVI values that were below 0.2 to account for mixed pixels or misclassification or being in cloud cover or shadows, because some of my 2023 imagery still had clouds, I think, in May. For my statistical analysis, I have 3 tests or results I'm going to share is done in Excel and RStudio. I summarized all the data and just was looking for patterns like the minimum, mean, maximum, standard deviation, and range. I'll show the overall mean values for each class as a bar graph to start. I have an independent samples t-test to compare the means between the 2023 and 2021 values of May and July, and evaluated the change in a line graph over distance to quantify the difference between NDVI values. I also used a linear regression test on a random sample of points within each class of the buffer rings to see if the NDVI values would change over distance. And I visualized these as color-coded scatter plots with regression lines per vegetation class. I expected that if vegetation health was impacted by the derailment and visible with remote sensing, NDVI values would increase as testing points grew distant from the derailment site. So this is my first bar graph where it shows the index values within each vegetation class. So the blue bar is May 2021, and then May 2023 is red, and then so on. There was a very noticeable change in May 2021 to 2023 across all of the classes shown in this figure. This was initially very interesting to me because I thought that May 2021 values were typical for May without any additional controls. However, there were minor changes between July 2021 and 2023. Overall, the NDVI values decreased by 0.187 from May 2021 to 2023, which is huge since NDVI is only measured on a scale of -1 to 1, and vegetation will always be higher. So that's why it should be 0.2 and up. And then between May and July 2021, there's a decline of NDVI to 0.179, whereas between May and July of 2023, the values remained more stable during that period. This is my independent t-test used to compare the NDVI means between May 2021 and 2023, as well as between July 2021 and July 2023. The null hypothesis is that there is no change, while the alternative was that there is change. The results showed a significant change for all classes, where even though July, it was just a small change between -0.056 and 0.009. The line graph illustrates that July's data low near the derailment is low near the derailment at 1 mile buffer, which is, it's still not very low. It is a difference at least, with the mean differences increasing to the third mile buffer and then decreasing again in the 5th mile buffer, which shows more variability between the buffer rings. The May mean differences remained more consistent over distance, but are overall higher, which is not surprising considering the difference that we saw in the bar graphs. There's still a slight peak in the 3 mile buffer. But if derailment distance impacted the NDVI means, I'd expect to see a more pronounced difference closer to the derailment with less variance and increased distance approaching 0. This is a lot of data right here, but I'll explain. The scatter plots are represented in figure 11 show my linear regression analysis for NDVI values. The May scatter plots are on top and the July ones are on bottom, with 2021 on the left, which is just used to examine the change between 2021 and 2023. And then the 2023 ones are on the right. The crop points are red and forests are green, and the grass pasture values are blue. So the NDVI values are ranging from 0.2 to 0.7 mostly, except for in May 2021 where they go up to 0.9. The plots use 40 random points per buffer ring and class to compare the data. In July 2023, there is a slight NDVI increase in the forest class over distance, and that can also be seen in crops for May and July of 2023. However, NDVI does remain really stable for grass and pasture, The scatter plot's dispersion suggests a really weak link between distance from the derailment and NDVI, though. The linear model in this analysis assumes that there's a relationship between distance and NDVI. There's a low R² values that indicate little of the NDVI variability can be explained due to the distance from the derailment, except for in the crops class of May 2023, where it explains only 4.8% of the variability, so it's still not very much. The grass pasture class shows the weakest relationship with slope values of almost 0 and very, very low R² values. It is important to note that the limited NDVI range will affect the slope values, and they're for a small change in NDVI, which was 0.39 to 0.5 in crops in May 23. That was the biggest change in the overall range. That's a big difference for NDVI values. The slopes could have been impacted by my sampling strategy since the points were kind of more clustered within the 1 mile buffer with 40 points and more spread out over the other buffers. So because May 2021 was so different, it made me concerned if that was a good indicator of what NDVI values are typically like in this area that time of year. So I acquired more Sentinel-2 imagery for May 21st and July 25th of 2020. And the July values remained really consistent across all years. So I didn't include that here, but in figure 12, you can see the orange bars are the May 2021 values, which shows they had a overall about an NDVI value of 0.2 higher than all other years across all the classes. It could be because this is the first day of the month versus 20 days later, which 2020 and 2023 are both from the 21st. This could be maybe extra moisture caused from spring rains. Maybe they planted some early crops that could be throwing off the numbers, but it's outside of the scope of my project to investigate that further since it's before the derailment. So in conclusion, there was my goals were to assess the changes following the East Palestine train chemical spill caused by the train derailment. And the independent samples t-tests indicated an overall change in NDVI from 2021 to 2023, but linking it to the derailment would require more data, and the July data showed very minimal change. And May 1st, 2021 was probably not ideal for comparison due to the seasonal variation or plant changes or whatever that made it so much higher. Had I thought this could happen, I would have maybe compared NDVI values over multiple May months in Google Earth Engine before selecting a date for a control. The linear regression plots suggested that crops were affected with NDVI rising over distance in May 2023 and July. But enforced as well in July. But the distance didn't explain very much of the variability according to the R² values. And the other goal of my study was to see if remote sensing could be used in analyzing post-spill imagery for vegetation monitoring and be effective using spectral indices. And it seems like it's still inconclusive. It's important to note that if there was a noticeable decrease in NDVI, it would be very concerning. So possibly the EPA and Norfolk Southern's actions might have mitigated some of the potential negative outcomes a bit. Without their swift response, the outcomes might have been different, although I'm sure there was always more that they could have done. To improve the study or next steps for the study, I would have selected different vegetation indices to start that were more well documented. I got pretty far with GNR and GSWIR before I realized that I didn't understand what the outputs really meant. And they're not really mentioned. They're mentioned briefly in other research, but not interpreted. The seasonal challenges, the timing of the derailment in February made it difficult. Utilizing vegetation indices would have been more effective if the derailment occurred in spring or summer months when vegetation is more discernible. The delay in the selection for imagery too, after 3 months after the derailment, made it harder to link to the results of the derailment. So if I found a different chemical spill in early, like in the summer months or in a warmer area, I might have had more interesting results. I would have adjusted my methodology too. My initial plan, I wanted to use eCognition to do a manual classification using a Geobia or geographic object-based image analysis with LiDAR data, but there was limited LiDAR coverage to make an NDSM and differentiate my vegetation types, so I had to go with the USDA crop cover data layer. I'd also expand the scope using a control area apart from East Palestine, looking at other chemical spills, and using imagery from different years, and extending my study area beyond the 10 miles from the derailment site could reveal broader impacts over greater distances. I also think that this could have been benefited since this is kind of interdisciplinary. I'm not a botanist or expert in agriculture or chemistry, so having someone to work with that could help with like ground truthing and doing soil samples to confirm if any changes in NDVI were related to the derailment or not would have been very beneficial, I think. And that's my presentation. That's pretty much everything. It was inconclusive, but I learned a lot over the study, and I think if I were to approach this again, I could have done a lot more, I think. Are there any questions?
All right, Laura, thanks for a very thorough investigation of potentially what could have been a huge catastrophe. Not that it wasn't, but it could have been a whole lot worse. So great job on that. You have some questions come up in the chat window, so if you could respond to those, that'd be great.
Okay. Oh yeah, I did create interpretation keys in eCognition. That was helping me a lot because I was trying to figure out what the G near and G square results meant. And it was interesting, and it kind of made me realize that maybe the May values were a little crazy too when I was doing that. Because when I originally was trying to approach this, I did start in eCognition. It was very interesting, but it's very difficult to separate vegetation without a height differential. Thank you, Christine. David. Oh yeah, the slope and wind factors for the potential spread of chemicals. There's definitely a lot that you can look at there. I was originally going to do that. I was trying to use a broader approach because it was kind of overloading my brain to try and figure out how they could have spread from all of the different ways, because vinyl chloride can be in a liquid form or in a gas form. And one of the research papers I read was about all of the different compounds that can be created after the burning too. So it was enough to make my head spin as not a chemist. There's definitely a lot more to consider there though. Beth. Oh yeah, the lack of communication for research mitigation. I have not listened to the Allegheny Front on NPR. I would be really interested. Oh yeah, that would definitely be interesting. I should look into that for my it's a little awkward. One of the reasons I wanted to take Geography 870 and not present this capstone more widely is because my company sells parcel data, and one of one of our customers is Norfolk Southern. So which happened after I started this. So it is a little awkward for me. What other environmental factors could you explain interannual differences in NDVI, and could you account for these differences? Yeah, there's definitely other ways that I could account for the NDVI rather than just using the date, the prior imagery as a date for control. But there's a lot of different ways I could have approached this, which it's a hindsight 2020 thing. That I go into actually in my paper and discuss as well.
All right.
All right, thanks.
Yeah, thanks, Laura. Great presentation. Maybe you could put your contact info in the chat window in case someone wants to contact you about a follow-up question.
Yeah, sure.
And then, Jack, if you want to go ahead and start sharing your screen, we can get your presentation rolling.
All right, just a moment.
All right, we see your screen.
Okay.
So go ahead and start when you're ready.
All right. My capstone project is asset management using GIS for small water and wastewater utilities. My name is Jack Rosenblit. I work for a company called Rural Community Assistant Corporation. It's a nonprofit out of West Sacramento, California. We're part of a national organization called Rural Community Assistance Partnership, and which there's multiple companies like ours within this partnership. I think there's 5 or 6, and we do the most western states in the Pacific territories. We're funded through a lot of federal contracts, through like EPA, USDA, HHS, and state contracts. So pretty much all that water infrastructure money that goes out, that's been going out, under those contracts, there's money for technical assistance providers to help communities apply for that money. So that's a lot what we do at our company, is go and help communities apply for these infrastructure grants. And a big part of a lot of these grants is wanting GIS and asset management. So again, I'm going to pretty much look at asset management as a maintaining desired level of service for you want your assets to provide for your life cycle cost. This is very much defined by EPA. A lot of people use this EPA definition in this guide that they put out in 2008. So pretty much an asset is all equipment and infrastructure of a water utility: pipes, pumps, valves, vehicles, buildings. And then GIS, we use to map out these assets, mostly hidden underground. So we can use the GPS, GNSS technologies for high accurate location information. The data is exportable into an asset management plan. And then it's great to put notes on what you've done to the assets in the field. Pretty much our project goals and objectives. The main project is make a prototype GIS asset management for small water and wastewater activities. When I first started working at my company, the GIS looks like it was really not being used. We set up, backing up a little bit. So we set up 4 communities can come into our GIS environment. They get access for a year free, and we go out there, help them field map their assets, give them some training, and they get to stay within a group within our GIS environment. And what I was noticing is no one was using it. These communities would get their training, get some initial points on the map, and that was it. And they wouldn't be logging back in or using it at all. The quality of the data was pretty poor. It looked like that they were just using the field map application. Distribution lines were not connecting to each other. There's many topology errors. Distribution lines should go through valves, and a lot of these maps, the valve point was not even near the distribution line. So there was a lot of issues. So I was looking to pretty much develop a system that can get the communities to want to use more accurate data and really have it so it could be used as an asset management system. So I was going to make this a web application to go along with the field maps and the Esri Experience Builder application, which is something that I haven't really used much before working on this project. So previous research, asset management. Schultz suggested that asset management is a strategic point to optimizing cost effectiveness, the balance of maintenance and new investment. It's pretty much needs to be optimal and sustainable as possible. And then again, the EPA Asset Management Framework 2008 is very common referenced upon. A lot of our asset management training at my work is completely taken from a lot of EPA's information. Critical assets, we define those as side or high risk of failing. Listed criteria used to score critical assets. Pretty much we take possibility of failure, multiply it with consequence of failure, the higher number of those assets that are really likely to fail, and you really need to watch those assets. There's also the life cycle cost, pretty much the cost to determine when the asset should be repaired or replaced. Pretty much as you first install your asset, it starts degrading, and there's a point where it's okay to repair that asset. And then after that, there's a point that it's no longer cost effective to repair, and there's a point that you just need to replace. And that's one reason why life cycle and estimated life expectancy is a big attribute that's used for asset management. And looking at GIS for asset management, we covered the importance of using GIS information for using GPS, GNSS technologies, especially for your buried assets. I was out field mapping and a valve got covered by gravel because it was over by a road and they redid the road. We had to use a metal detector to find the valves. So by using the GNSS, we can get within a meter or two to that location. So it's a lot less digging and looking for the buried assets in the field. And I looked up some research on prototyping new solutions. Pretty much looking at effectiveness, usefulness, user reactions, giving us tests to score how the prototype and the application works. Okay, so I'm going to go into data sets. So I initially developed a hypothetical drinking water system to be created to test out the application. This will also double as a future training tool when showing people GIS. We do a lot of GIS trainings at my work, or not a lot, but I usually do them like 2 to 3 times a year, showing communities how to use GIS. These later data sets will cover the assets a small water wastewater system would map, attributes chosen for each layer, need to provide as much information as possible to be added to an asset management plan. So one of these main types is pretty much your date install, the criticality and the condition. Pretty much when you're going out there mapping, you want to really assess the asset. And then you can multiply criticality condition to get your critical score, use your life expectancy. Now the system ID is very important if someone has an actual asset management system. The reason for that is so you can make sure that your GIS has the same naming as your asset management system to be able to do joins on the data both ways. So as long as you have that field that matches a field from another Excel, it's really great to be able to just put that information straight into your GIS if it's already in your asset management system. So the methodology. So how we actually, the future process in an actual situation where we're going to map for the community is we determine the mapping needs of the utility. Pretty much I have a list of all the assets and we talk to the community and ask them if they want to map those assets or not. We create a feature layer based on what assets they want to map. Then we will share that to ArcGIS Online as a feature data service. Create a web map to be used for field maps and experience builder. I usually have 2 different maps because I like to use live parcel data. So if I can get the live parcel data that goes on the web map for the experience builder, but the field map can't use that. So sometimes I'll then download that parcel data and clip it to be used in field maps. So I have two maps that feed two different products, but they use the same feature data set, so they both update each other. We go collect the data in the field, and then you can update the data in this new Experience Builder application as needed in the office. Here's the initial prototype that I made. Pretty much I like initially have the legend show and the layers show at all times. This is a pretty much a fake water utility that I made up myself for testing purposes, so we didn't have to use someone's real data. Basic editing function. There's a select function which changed between the start of this project and the end of the project. You didn't used to be able to select and export in Experience Builder, but now you can. Just a table function to be able to view information on the table, a draw function so someone can mark up the map, add data if someone wants to add some data from the ArcGIS Online, and then a base map switcher, and then just this address geolocator, which I actually learned today that you can actually set your geolocators to a set area. So if you want to be able to set your address locator to just see addresses within the service area, you can add that to ArcGIS Online. So it was a very interesting find today. It helps a lot with lead service line inventory. So a methodology for the application testing. The Experience Builder application will be tested internally and externally. A group of testers will be selected to test the application. A list of tasks will be given to perform while testing. Interviews will be done after testing and feedback, and to make updates to the application. And then the right is kind of the example of the tasks that I used. Pretty much use the search function, click on the data, be able to edit that data, use the select tool to export out. Of course, when I wrote this, you had to use the table function to export. So this was based on using the table function instead of the select and export, which was added in the middle of working on this capstone project. So the results, unfortunately, I gave it to at least 10 people and I got 2 answers. The people were given hours, legitimate reasons to test. I talked to people after the fact it was too late to add more data, and then they were just scared to not do it well and to give bad answers. And so it's definitely feel the pain of trying to test out an application and just not get people to actually do it. Definitely some issues were brought up to be changed. One of the issues was brought up in one of the earlier capstone products today, that the default zoom in from the search zooms in way too far. So I definitely modified that to not zoom in so far. Some of the issues were just the functionality of Experience Builder. Like the editing is, I feel in Experience Builder is a lot harder than the old web application that used classic map. So there was definitely some issues that are not something I can directly change because there's still limitations in Experience Builder compared to the old web app builder. I was actually able to use the test template into a practical use in the field. I was able to do that early April, so I was able to add some results. Definitely some issues came up in the field that needed to be addressed. For some reason, Experience Builder wasn't letting the mobile workers edit, even though they were given permissions. Weird Esri bugs. I had to change the sharing to the whole organization, which I don't want to do because the whole point is because we host multiple communities that only the community has access to their data. That fixed the issue, but then I luckily was able to change it back to just the group sharing and it worked. So I don't know what went on there. There was layers not syncing in field maps, and I had to go and go in and the ArcGIS Pro, update the layer, bring it back up. Just a lot of weird issues that it doesn't make sense. And working in GIS field, I just sometimes found weird bugs that there's like no explanation. You just kind of have to take it down and bring it back up and see how it works. But overall, the community we worked with really liked the application, and it was a good experience. The main conclusion is, yes, it's hard to get people to test projects. Issues coming up field work. Definitely need to consider monitor size when creating web applications. I have 27-inch monitors, so it's easy to see everything, but the last field work we did, they had little tiny monitors, so having like the layers in legend field being up at all times, that greatly limits the user space. So I really need to consider the customer or the community on when we're designing these, not one template fits all. There's Experience Builder is constantly updating. It's one reason why I didn't start using it when it was newer, like in my previous job, especially since we were using Portal, and Portal was even further out of date compared to the updates going to ArcGIS Online. So it's just dealing with the constant changes of Experience Builder. I have now created a test account that has the mobile user ID permissions to make sure each time I make an app that mobile worker can use it. Because when you're the admin, you can do everything. So I just need to make sure that everything I create is usable by a mobile worker. And then just future work is to continue updating based on feedback in the field. And right now I am working on a guide to link to the application to help people with the applications, like especially with working with the wonky stuff on how the editing tool works. I really wish there was ways of changing it. But right now we're kind of limited to what Experience Builder gives us. And I'm working on incorporating Survey 123 for lead service lines into the Experience Builder application. So here's just the list of my references. And then, yeah, so any questions?
All right, Jack, thanks for a great presentation. Looks like you have a question in the chat window for you.
Let's see. I'm just trying to understand the question. So we only work with like the very small utilities. Like technically we can work up to 10,000 people, but we stick to usually less than 1,000, 2,000. People kind of learn about us through the grant process, like EPA and USDA will refer people to us to help them. And we also do a lot of trainings. So because we do a lot of those trainings, people get hooked up with us to help them through those trainings. And we go to conventions and different conferences. I haven't looked into having it produce topology areas within the web application. I'm not sure if that's if that is possible or not. Definitely maybe something down the road. The main thing that with the topology is being able with the web application is being able to snap, which you can't do on field maps as well. So that itself is a big help compared to people attempting to draw lines on their tablet through field maps. Cool. I will definitely look into that more. That will be helpful. Yes, I definitely learned that about configuring the Experience Builder based on screen size. So that's definitely something I've been looking at and working on. Thank you.
All right, Jack, thanks again for your presentation, and thanks to all those that took time out of their day to present. Great job, everyone, and thanks to the audience for coming out and asking some great questions. So this concludes our Friday afternoon version of JRF 870 capstones. If you are interested, Monday, 6 p.m. Eastern, we'll have another set of presentations. So mark your calendar to join in. Otherwise, everyone have a great rest of the day, and we'll see you later.